Welcome to part four of our series on beer. And we left off last time talking about malting, and here we're going to talk about fermentation. Fermentation is truly the original nanotechnology, things that happen with particles so small that you need a microscope to see them. And fermentation happened in a lot of different places. It happened with alcohol and bread and cheese and pickling. And they were probably all originally produced not necessarily by accident, but just by happenstance. No one planned to make any of these things. Probably started 10,000 or more years ago. Well, it did start way more than 10,000 years ago, but 10,000 years ago we started to domesticate yeasts in order to produce alcohol. And that's the focus of this talk. And it's the same yeast that's used to make beer that is used in baking. So that one yeast has had a lot of different uses. The other big change in this field of alcohol is about 2,000 years ago, distillation became a real thing. And distillation is used to concentrate alcohol. So that mix that you get in the vat when you're making beer, if you take that and distill the water off of it, or more correctly, the alcohol off of the water, you're going to get a distilled spirit. The point of bringing this up at this point in time is here at the bottom that all along the way, people are looking for new uses of technology to make better product, and that's going to be the way it is. Particularly in the United States, we are big on innovation and new use for things. So fermentation, quite simply, is just what yeast do when they convert what they eat, typically barley or some kind of grain, into energy. And it's really quite parallel to what happens when we eat. We eat all kinds of food, and our bodies process it, and it gives us some energy, and it creates some waste products. So, same thing going on with yeast. That ethanol happens to be both a source of energy and a waste product from yeast, which for us is pretty cool. The yeast utilize the enzymes in the grains to convert sugars into acetaldehyde and then into ethanol in a two-step process with a couple of different enzymes. One that actually turns acetaldehyde into ethanol, and a second that does the reverse. So there's a little bit of a competition going on. And those two enzymes, alcohol dehydrogenase 1 and 2, are almost exactly the same. They're less than 10% of the amino acid sequence is different. So it doesn't take very much to go back and forth between those two. There are a lot of people studying fermentation, but there's so many variables that you have to be careful how you study this. So I found in my research for another class that I taught that there's a place called White Labs, which is near San Diego, California, and they have a very interesting setup. Their tasting room has 28 different taps. Now, you would maybe wonder why a company that sells yeast has a tap room with 28 different kinds of beer. Well, here's the answer. All the beer is made with exactly the same barley, and it may be set up on the same day, the same batch of barley. It's made with the same hops, it's made with the same water, and they're all made at the same temperature. So they're trying to control everything so that the strain of yeast is the only variable. And that way, if you're interested in a different yeast, if you're a home brewer, or even if you're with a big company like a Budweiser or a Miller who's making tons and tons and tons of beer, if you're looking for something new, these guys have 28 different kinds of yeast. Now, one of the experiments they did that was really interesting was they took two beers with identical ingredients, and the only variable was the brewing conditions. So the first sample was brewed at 66 degrees Fahrenheit, and that produced a beer with a green apple taste. And that green apple taste is due to only having 8 parts per million of acetaldehyde, which is a precursor to ethanol. This is way below what most people can taste. So this green apple taste is kind of a raw, greeny kind of thing. The second batch was brewed at 75 degrees Fahrenheit, and it had way more, 15 times as much acetaldehyde. That's above the taste threshold. So only by a matter of less than 10 degrees in the fermentation temperature changed the characteristics of the final product a great deal. And this happens a lot with different chemical and biological pathways. Another piece of research that has to do with wine I thought you might find interesting is the Gallo Winery. And Many of us know them because they produce some of those large glass jugs of wine that you serve when you're having pasta or big parties. They took the juice from Chardonnay grapes. They used a single batch. Again, scientists are trying to control the variables. There were 69 strains of yeast that were used in their experiments. And they did a rather extensive thing on the back end. They measured ethanol, but they measured 29 other chemicals in these batches to try to figure out what exactly was going on. They saw in these 69 batches up to 1,000-fold variation in some of the chemicals. So same juice, same everything, just a different yeast, a lot of different pathways leading to some significant variations in the chemicals in the final product, and that definitely affects the flavor profile. The other thing they found was these produced at different speeds. Some went very fast, some took a little more time. I'm sure there were some differences in quality, but I'm guessing that the speed did not line up with the variation or the preference for taste of the final product. But yeast is a very interesting creature. So in summary on fermentation, a lot of strains of yeast, too many to count. They all make ethanol, but every product tastes a little different. That pathway from glucose to ethanol, there are a lot of forks in the road. There are a lot of chemical side roads that the process can take. And any of you know the name Louis Pasteur? You should, because pasteurization is a part of every gallon of milk sold in stores in the United States. That's the process so that that milk doesn't have anything harmful that's going to make you sick. Well, he was the first one, if you recall, if you've watched all four videos in the series, we talked about in part 2 or part 3 that he talked about how, depending on what you start with, you get different products. So he also did some research on the kind of yeast. So Pasteur was very instrumental in understanding yeast and trying to figure out what it does and how it does its work. Finally, the last thing we need to talk about is bubbles. We need to talk about carbon dioxide because fermentation does have CO2 as its other product. And bubbles, whether you believe it or not, do matter. Now, those CO2 bubbles are what gives bread its little pockets, and you don't need to worry about getting drunk from bread, obviously, because the ethanol cooks out while the bread is being baked. Most people who make beer, in fact, do nothing to control the carbon dioxide content. They have things they can do on the back end if they need more CO2 in their beer. But carbon dioxide does bring some flavor to the party. And if you have a chance, if you're taking culinary chemistry right now, the demonstration you want to do is go out and buy 2 20-ounce bottles of your favorite carbonated beverage. I wouldn't waste money on 64s. I would do it with 20s. Set one aside. Make sure they're at the same temperature. The second one, I want you to shake a little bit and then very carefully open up the cap and let all that CO2 out. Try not to let too much of the pop out, just let the CO2 out. Shake it up again, release the gas. Shake it up again, release the gas until no matter how hard you shake it, there's hardly any gas that comes out. When you get to that state, I want you to take a sip of that product and then go get the other bottle, open it, and taste it. And you will see that that sharp bite that you normally get on the first drink and that you will get on the bottle that you didn't shake the CO2 out of is very different from the flat CO2. That carbon dioxide is something very important in that bottle. It wants to get out. It scavenges free radicals, so it's kind of good for us. It can make beer taste weird. It can make beer cloudy, which some people like cloudy beers. Um, but it's required in beers and champagne. It holds the product under pressure and it produces carbonic acid. And carbonic acid is that sharp taste that you feel on your tongue when you drink a beer for the first sip of beer or the first sip of pop. That's the CO2 combining with the water to form carbonic acid, and it gives a sharp taste on the tongue. In the bottle, the pressure that that bottle is under is actually forcing the CO2 to stay in the bottle because when you look at a bottle before you've opened it, you probably wouldn't even know that there's gas in there because the bubbles are forced into the solution. But when you pop the top or twist it off, you'll see bubbles streaming up the side of the container because the CO2 wants to get out of there. It really doesn't want to be in solution. It would rather be gas. Champagne has about 12 grams of CO2 per liter, and public safety announcement, the bottle pressure is about 6 times atmospheric pressure, which can propel the cork at over 30 miles an hour. Particularly if your champagne has a plastic cork, really be careful where you point that thing because it can do some serious damage. Might even take an eye out. Beer has about 5 grams of CO2 per liter, and typically it's a metal cap or a pop top, so it doesn't have a hard plastic cork that's going to do much damage. But the CO2 in beer does give beer a head of foam, and most of us, when a beer gets poured, if there's no foam, we're kind of suspicious that it's old beer and it's not very good. People like a thick head, just it's kind of like a quality check. And then we want lacing. We want to see streams of bubbles that are pushing foam up to the top of the beer because we think the beer is going to taste better and we think it's probably fresher. If you want to know how to pour beer, there's another YouTube link that'll be out on the Canvas site because actually you want to give it a little bit of height. You want to get rid of some of that CO2 to release the real taste of the beer. So it's an interesting competition between physics, which wants to pop those bubbles and let the CO2 release, and chemistry that wants to hold them together because they do contribute to the taste of the beer. Because the bubbles in beer attract glycoproteins, proteins, sugars, and these are surfactants. And they do a lot of things to keep flavor in place, and they change the way that the beer is processed on your tongue. The glycoproteins form a membrane around the bubbles, and that's what keeps them from popping because the foam in a beer lasts a whole lot longer than the foam, say, in if you pour a bottle of Coca-Cola, that foam goes away, no glycoproteins. And the glycoproteins make the bubbles stick together. Again, that's why the foam persists. If you want to know another reason, those bubbles are formed in the liquid and they gradually come up the liquid and they are reach the top and they are pulling liquid with them, which kind of stirs it up and produces a little more of the foam at the top. And then the liquid, gravity takes over at that point and the liquid falls back into the beer. And eventually the head is going to disappear, particularly if you have ladies, if you or anybody, because guys wear lipstick too. If you have lipstick or something to prevent chapped lips, that's going to make the bubbles disappear more quickly because there are chemicals in there that are going to help the bubbles disappear, and eventually the head disappears. So this is the end of our 4-part series. I hope you've enjoyed learning these things about beer. There's a whole lot more for you to know. We have not talked about the different products. We have not talked about all the different kinds of beer that are out there today. There are some trees that look like genealogy of where they all came from and why they existed. So if you're into beer, I encourage you continue to do research. Go to your local brewmaster. Brett Cotton is a good person here in Adrian, Michigan, and he'll talk to you until you're blue in the face, until you don't want to hear any more about all the stuff that he's learned about beer in the 10 or so years, 10 to 20 years that he's been producing beer. Take care. Hope you continue your quest to learn more and more about beer. Thank you for spending time with us. Bye-bye.